right, here we go. Quadratic patterns. Here's step 1, here's step 2, here's step 3. Notice it's growing by what? Yes, by a square. Quadratic, quad, square, yes. The square is growing. Step 1, 1. 1 times 1 is 1. Step 2, there's 4 blocks, right? 2 times 2 is 4. Step 3, there are 9 blocks. 3 times 3 is 9. Step 4 would be 16. Step 5 would be 25. How do you write this as a function? S of n is n squared. That's what makes it a quadratic pattern. It's because you have a square. Makes sense? S of n is the total number of small blocks. N is the step number. But what if you have this pattern, right? What happens here? Okay, so you can see the blue is a square that's growing. That's what makes it a quadratic, right? So that's the n squared part. But what do we do with these red blocks growing? They're also growing, but they're not growing as a square. They're not growing quadratically. They're growing linearly. Get it? 1, 2, 3. Every time you have a step increase, you have an additional red block. So what would the function be? S of n would be n squared plus n. Why does that make sense? Well, the n squared part is the square that's growing. Just the n by itself is the line that's growing. Step 1, you have 1 in the line. Step 2, you have 2 in the line. Step 3, you have 3 in the line. So how many blocks total at step 3, right? You have 3 squared plus 3. 3 squared is 9 plus 3 is 12. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Makes sense to me, and we're on to the next example. Whoosh. All right, now we have blue, red, and green. So what are we going to do with this? Okay, so first we see that there is a square that's growing. That makes us happy because we are in the quadratic unit and we are in the lesson of quadratic patterns. So there's probably going to be a square that's growing, and we see it right here. 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. So we got that. That's our n squared. We have not 1, but 2 red lines growing. That's the 2n. And what is this 3 all about? That's the constant. Those are 3 green blocks that never change. That is the constant, right? So here we have n squared plus 2n plus 3. How many total blocks in step 3? Well, 3 would be 3 squared, which is 9, plus 2 times 3, which is 6. So 9 plus 6 is 15, plus 3 more is 18. Do we have 18? Well, here's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yes, we do. And we're on to the examples. All right. First example, what do we have here? Well, we have a square that's growing. Oh, goody. That makes it a quadratic pattern. And what about these 4 blocks? They're not growing at all. Indeed, they are constants. Do we have any lines that are growing? No. There is 1 square that's growing, that's n squared. There are 0 lines that are growing, so that's 0 times n. And there's 4 constants, so it's n squared plus 4 for question 1. On to question 2. What do we have here? Yes, we do have 1 square that's growing, that's n squared. And we also have 1 line that's growing, that's plus n. And we have no constants, so we just have n squared plus n. And then you get to the third one, and because I can read your mind, you're like, oh, I thought I was good at this. I thought I was getting it. What in the world am I going to do with this? All right, let's get to it. First off, we have to recognize that there is indeed a square that's growing. You see the problem with it, though? It doesn't start at 1. It starts at 2. Step 1 is 2 by 2. What are we going to do with that? Step 2 is 3 by 3. Step 3 is 4 by 4. Well, step 1 is 1 plus 1. Step 2 is 2 plus 1. Step 3 is 3 plus 1. So whatever step you have, n, plus 1 squared, that's our quadratic part. All right, how many constants do we have? I don't think we have any constants, but we do have 2 lines that are growing, right? That's why there's a 2 here. The line here and the line here, they're each a line and they're each growing, but they start off not at 1, they start off at 2. Step 1 has 2 lines that start at 2. Step 2 has 2 lines that start at 3. Step 3 has 2 lines that start at 4. So again, it's the step you're at plus 1, and there's 2 of them. Whoosh, what are we going to do with this? Well, this isn't really in factored form or standard form or anything we're used to, but we can FOIL. First outer inner last, n times n is n squared. N times 1 is 1n. 1 times n is 1n. 1n plus 1n is 2n. 1 times 1 is 1. So there we have the FOILed of n plus 1 squared. Distribute the 2, you have 2n plus 2. Combine like terms. 2n plus 2n is 4n. 1 plus 2 is 3. N squared is there. And we are good to go.